For example 1, two forces are acting on the object, normal force and the force of gravity. Because the object is at rest and the forces in the x and y directions are balanced, the normal force is drawn perpendicular to the ground surface, while the force of gravity is pulling downwards. To find the force of gravity, the object's mass, which was in pounds, was converted to 52.19 kilograms and was multiplied with acceleration, negative 9.81 meters per second squared, to equal negative 511.69 newtons. Because the two forces are balanced, the normal force can be calculated by finding the net force in the y direction, which includes setting the force of gravity and the normal force to 0, making the normal force positive 511.69 newtons.
For example 2, two strings are holding the box up, causing two tension forces. Because the box is at rest, the x components and y components are balanced. Tension 1 and tension 2 are balanced because they are at the same angle. To find force of gravity, multiply the mass of 0.13 kilograms with acceleration, negative 9.81, which equals negative 1.275 newtons. To find T1 and T2, multiply the tension with sine theta. However, because we know the components are balanced, the tension forces should equal. So we find the net force for y components, which essentially is 2ft plus fg, or negative 1.275 newtons. We end it with 0.64 newtons per ft.
First, when drawing the force diagram, since the box is being pushed across a flat surface, normal force, the force of gravity, applied force, and kinetic force are all acting upon the moving object. First, the force of gravity was calculated by multiplying negative 9.81 to 0.13 kilograms, which is the mass of the box. The force of gravity came out to be negative 1.275 newtons. Since the normal force and the force of gravity are balanced, the normal force is positive 1.275 newtons. Next, the force applied to the box at 180 degrees was calculated by applying the same amount of force used to push the box across the table to the box while it is on the scale. Then, subtracting the mass of the box from the mass of the box with the applied force, the applied force was calculated to be 0.012 kilograms. However, in order to calculate the applied force in newtons, 0.012 kilograms was converted to pounds by multiplying 0.012 kilograms by 2.204 pounds, equaling 0.0264 pounds. Next, 0.0264 pounds was converted to newtons by multiplying it by 4.45 newtons. As a result, the applied force was calculated to equal 0.11748 newtons. Since the applied force and kinetic force are balanced, the kinetic force equals negative 0.11748 newtons.
For example 4, the box is being pushed by two forces on the table. Fa1 is greater, which cancels out Fa2 to keep the box moving at constant velocity. The kinetic friction at the same direction with Fa2 together balance out Fa1, hence constant velocity. Because it's on the table, there is a force of gravity and normal force, which are balanced to ensure constant velocity. We already have the mass of the box, 0.13 kilograms. To measure Fa1, we apply the same force on the box on the weigher to find 0.426 kilograms. By subtracting 0.13 kilograms from 0.426 kilograms, we get 0.296 kilograms. To convert 0.296 kilograms to pounds, we multiplied it with 2.2046 pounds because 1 kilogram equals 2.2046 pounds to get 0.652 pounds. Then, multiply 0.652 pounds with 4.45 newtons to get 2.903 newtons for Fa1 because 1 kilogram equals 4.45 newtons. For FA2, we followed the same method by weighing the applied force to get 0.142 kilograms minus 0.13 kilograms to equal 0.012 kilograms. We multiplied 0.012 kilograms with 2.204 pounds to get 0.0264 pounds. Multiplied 0.0264 pounds with 4.45 newtons to get 0.117 newtons for FA2.
We are able to calculate kinetic friction by solving the net force equation in the x direction. Because the object is moving at a constant velocity, we are able to add FA1 plus FA2 and kinetic friction and set them to 0. After plugging in our values for FA1 and FA2, we are able to find the value for friction, negative 2.785 newtons. To find the force of gravity, the object's mass, which was 0.13 kilograms, was multiplied with acceleration, negative 9.81, to equal negative 1.275 newtons. Again, because the forces are balanced, the normal force can be calculated to become a positive 1.275 newtons.